Hi, this is Srikanth S, Assistant Professor of EEE Department. In this session, I'm going to cover the definitions on bipolar junction transistor and their application. Define BJT. BJT is a bipolar junction transistor is a three terminal electronic device constructed of doped semiconductor material. It is a three terminal device which is constructed by a three layers which is going to be doped in a different levels, and these doping levels are going to have, that is, there are two different types of transistors are available, PNP and NPN transistors, and this is like a sandwich between uh, the braid, that is P, between the two P layers one N layer is going to be placed, between two N layers one P layer is going to be placed. Why are the BJT so called? The bipolar transistors are so named because their operations involves both electrons and holes. Here these bipolar transistors are going to work on the both electrons as well as the holes. So the charge flow in a BJT is due to the bidirectional diffusion of charge carriers across a junction between two regions of different charge concentrations, between the two regions of different charge concentrations. List the types of bipolar junction transistors. Here the NPN and PNP transistors we are going to have, where the NPN transistor has one P region between the two N regions, whereas the PNP transistor has one N region between two P regions. That is, here if we take the layers, three layers, this is the P, N, P, and the next layer will be NPN, N, P, N. These are the three layers which we are going to have in the bipolar junction transistors. What are the possible ways of connecting bipolar? What are the possible ways of connecting the bipolar transistors? There are basically three possible ways to connect bipolar transistors. One is common base configuration, which has voltage gain but no current gain. The common base configuration has voltage gain but no current gain. Whereas common emitter configuration, which has both current and voltage gain. The common collector configuration, which has current gain but no voltage gain. These are the three different possibilities of connecting the bipolar junction transistors. Define active region. In this region, the base emitter junction is forward bias and the base to collector junction is a reverse bias. This region is the normal transistor operation mode for amplification and is characterized by the transistor current gain value. Here, when the base to collector junction or base to emitter junction is forward biased and the collector junction is reverse biased, then the transistor will be working in the active region. So in this region, the normal transistor operation mode for amplification and characterized by transistor current gain value. Define cutoff region. In this region, both base to emitter and base to collector junctions are reverse biased and the transistor acts like a open switch. So when both the terminals are reverse biased, that is base to emitter and base to collector junctions are reverse biased, the transistor is going to act like a open switch. And define saturation region. In this region, both base to emitter and base to collector junctions are forward biased and the transistor acts like a closed switch. Here both base to emitter and base to collector junctions are forward bias, so the transistor is going to act like a closed switch. That is nothing but a short circuit. What is CE, CB and CC configurations? The transistor configurations CB, CE, CC with characteristics accordingly. A transistor can be connected in a circuit in the following ways. One is common base configuration or grounded base configuration, common emitter configuration or grounded emitter configuration, and common collector configuration or grounded collector configuration. What is the principle of CB configuration? The transistor characteristics for CB, CE, CC transistors, the common base configuration of transistor, the base terminal of the transistor will be connected between the output and input terminals. Here, the base terminal is connected between the both collector and emitter. So the variation of emitter current with base to emitter voltage keeping collector base voltage constant. What is a transistor? A transistor is a semiconductor device which transfers a weak signal from low resistance circuit to high resistance circuit. That is nothing but a weak signal is going to be converted from low resistance circuit to high resistance circuit. That is nothing but from input to output circuit. State operating point. The operating point of a device, also known as bias point or quiescent point or Q point, is the steady state DC voltage or current at a specified terminal of an active device, such as a transistor with no input signal applied. Here it is the point where a steady state DC voltage or current at a specified terminal of an active device such as a transistor with no input signal applied. Define AC load line. Whereas the load line drawn under the conditions when an input signal along with the DC voltage are applied. Such a line is called AC load line. Define DC load line. The DC load line is the load line of the DC equivalent circuit defined by reducing reactive components to zero. That is nothing but inductor capacitors are replaced with a short circuit or made with zero, and it is used to determine the correct DC operating point, often called the Q point. List the terminals in BJT. BJT is a semiconductor device constructed with three doped semiconductor regions: base, collector, and emitter. Explain the breakdown voltage in transistors. The current is due to the movement of minority carriers across the junction and is independent of the applied reverse voltage. If the reverse bias voltage is increased to a large value, the current through the junction increases abruptly. The current through the junction will increase suddenly. This abrupt increased voltage is known as breakdown voltage. Suddenly, at a particular point, the current will increase to maximum. This particular point is called a breakdown voltage. Define early effect or base width modulation. The variation in the effective width of the base in a bipolar junction transistor due to a variation in the applied base to collector voltage. Here the variation in the effective width of the base in a bipolar junction transistor is due to the variation in the applied base to collector voltage. How the transistor will act as a switch. In a transistor, unless a current flows in a base circuit, there is no current can flow in the collector circuit. Once the base current will flow, then only current will flow through the collector circuit. This property will allows a transistor to be used as a switch. So when we give the base signal, then only the transistor will conduct. Define switch. Switch is nothing but it is an electrical or mechanical device designed to interrupt or divert the flow of electric current in a circuit. It serves as a control device allowing users to open or close a circuit manually or automatically. Switches are fundamental components in electronic and electrical systems, which providing a means to turn the devices on or off, control the flow of current and manage the operation of various electrical and electronic components. Define insulator. An insulator is a material that does not conduct electric current easily. In insulators, the electrons are tightly bound to atoms and they do not move freely in response to an applied electric field. As a result, insulators have high electrical resistance, meaning they resist the flow of electric current. Define the layers in transistors. A BJT consists of three semiconductor layers: emitter, base, and collector. In an NPN transistor, for example, the layers P type, N type is going to have the negative, and P type is going to have positive, and N type is going to have the negative. In the same way, for PNP transistor, the layers are P type positive, and N type is negative, and P type is again positive. Describe the modes of operation in transistors. The transistor operates in the active mode when a small current flows between the base and emitter. When a small current will flows through the base, then the transistor will be in active mode, which a transistor is a current control device. So the base current is going to be controlled. The controlling a larger current between the collector and the emitter. And cutoff mode. In cutoff mode, there is no base current and the transistor is in the off state. In cutoff mode, there is no base current and the transistor is going to be in off state. There is no conduction will takes place in the cutoff mode. And saturation mode, the saturation mode occurs when the transistor is fully turned on and there is a maximum flow of current between the collector and the emitter. So both are fully turned on. So the maximum flow of current will be there from collector and emitter. Describe the currents in the transistor. Here, emitter current, the total current flowing into the emitter terminal, which is the sum of base current and the collector current, where IE is equals to IB plus IC. The collector current, the current flowing from the collector to the emitter terminal is called collector current. Base current, the small current flowing into the base terminal that controls the larger collector current. Describe the voltage drops in the transistors. VBE is the voltage between base and emitter. The voltage drop across the base and emitter junction is called VBE, that is voltage between base and emitter. VCE is the voltage between collector and emitter. The voltage drop across the collector and emitter junction. Classify the transistor configurations. There are three different types of transistor configurations: common emitter, the common collector, and common base. The common emitter is the most common configuration where the emitter is the common terminal. And common collector, the collector is the common terminal, the remaining base and emitter is going to act like a input and output terminals. And in the common base configuration, the base is the common terminal where the emitter and collector are the input and output terminals. Describe the frequency response in transistors. BJTs have a limited frequency response and their performance may degrade at high frequencies. These BJTs are going to have limited frequency response and their performance may degrade at higher frequencies. This limitation is important in high frequency applications. Define doping. Doping is a process in the semiconductor manufacturing where impurity atoms are intentionally added to alter the electrical properties of the materials. Doping is a process in a semiconductor manufacturing where impurity atoms are intentionally added to alter the electrical properties of the material. And in the context of transistors, which are commonly made from semiconductor materials like silicon, doping is crucial for creating the necessary p-type and n-type semiconductor regions. Describe p-type doping. In p-type doping, a small amount of trivalent impurity, an element with three valence electrons. In p-type doping, a small amount of trivalent impurity is added to the pure semiconductor material. The common trivalent dopants include boron and aluminum. The addition of trivalent impurities creates holes in the crystalline lattice. As there are fewer electrons than needed for complete covalent bonds, these holes act as positive charge carriers. Describe n-type doping. In n-type doping, a small amount of pentavalent impurity is added to the pure semiconductor material. The common pentavalent dopants include phosphorus and arsenic. Here in n-type doping, a small amount of pentavalent impurity is added to the pure semiconductor material. Common pentavalent dopants include phosphorus and arsenic. The addition of pentavalent impurities introduces extra electrons into the crystal lattice, serving as negative charge carriers. Describe the doping levels in the transistors. The combination of the combination of p-type and n-type material is essential for creating the different semiconductor regions in the transistor. Here NPN transistor, the emitter is heavily doped n-type material, the base is lightly doped p-type material, collector is moderately doped n-type material. The PNP transistor, the emitter is heavily doped p-type material, the base is lightly doped n-type material, the collector is moderately doped p-type material. So based on this doping levels, the conduction in the layers is going to changes. Describe input characteristics. The input characteristics of a transistor describe its behavior in response to the variations in the input parameters, typically the base current and the base to emitter voltage for a bipolar junction transistor. These characteristics are essential for analyzing and designing the transistor circuits. The input characteristics are often presented in the graphical form. In this session, we have discussed the definitions on transistors and their applications. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.